Welcome to qnawire.
Okay, in this problem, we have a body that is sliding down on a inclined plane. It moves zero point 0.5 meter after zero point 0.5 seconds. Now, this problem asks how long will it take for the body to move another zero point 0.5 meter. So let's denote this as the sub and x sub 2 is 1 meter, since this is the total distance traveled. To solve this problem, we will use kinematic equations. First, we need to determine the acceleration of the body as it moves downwards the inclined plane. As such, we will use this displacement equation. X sub 1 is equals to x sub naught, the initial distance, plus v sub naught x, the initial velocity multiplied by the t sub 1, or the time after it reached the first 0.5 meter, plus 1/2 acceleration along its movement, a sub x, multiplied by the t sub 1 squared. Since the initial position of the body is 0, and it started from rest, then x sub naught is equals to 0 and v sub naught x is equals to 0. Then the equation becomes x sub 1 is equals to 1/2 a sub x multiplied by t sub 1 squared. Isolating a sub x to the left side of the equation, we have a sub x is equals to 2 multiplied by x sub 1 over t sub 1 squared. Inserting in this equation the given values, we have 2 multiplied by 0 0.5 meter over 0 0.5 seconds quantity squared. The answer is 4 meter per second squared. So this is the acceleration of the body as it slides down the inclined plane. Next, we need to know what is the velocity after 0.5, the first 0.5 seconds. We will use now the velocity formula, which is v sub ix is equals to v sub naught x plus a sub x multiplied by t sub 1. Since we know that the initial velocity is 0, the equation becomes like this. Since we already calculated the acceleration, we just plug in this equation. Then we have the velocity after the first 0.5 seconds is 2 meter per second. Now, to find the time it will take to reach 1 meter, we will use again the formula for displacement, which is this one. X sub 2 is equals to now x sub 1 plus v sub 1x multiplied by the time that we are looking for, t sub 2 plus 1/2 multiplied by the acceleration, a sub x, and then the time, t sub 2 squared. Since we are looking for the t sub 2, we can write this equation like this, since it is in the form of quadratic equation. Okay, let's just use t to avoid confusion. Thus, the equation becomes 1/2 a sub x t sub 2 squared plus v sub 1x t sub 2 plus this quantity x sub 1 minus x sub 2 is equals to 0. Inserting in this expression the given values we have, then 1/2 4 meter per second squared multiplied by t sub 2 squared plus v sub 1x, or the velocity 1, which is 2 meter per second, multiplied by t sub 2 plus x sub 1, distance 1, which is 0.5 meter, minus the distance 2, or the final distance, which is 1 meters, is to 0. Simplifying, we have 2 meter per second squared t sub 2 squared plus 2 meter per second t sub 2 minus 0.5 meter equals 0. To solve for t sub 2, we will use the quadratic formula, which is t sub 2 is equals to negative b plus or minus square root of b squared minus 4ac over 2a. Inserting the coefficients we have, wherein a is equals to 2, this one, b is equals to 2, this one, and c is equals to this one. C is equals to negative 0.5. you have negative 2 plus or minus square root of 2 squared minus 4 multiplied by 2 and negative 0.5 over 2 multiplied by 2. Solving this equation, we have of course we'll just only get the t sub 2 value with positive sign, since what we're looking for is time. And of course, it will never be negative. So the answer is 0.207 seconds. Therefore, it will take 0.207 seconds to reach 1 meters, given that for the first 0.5 second, the distance is 0.5 meter.